Good morning, dear students. Today we are ready to start second chapter. I hope we have had a good discussion of chapter 1. The last topic, vectors, of course needs more practice, and I have given you a worksheet in which some basic ideas are discussed, and you can put to practice some of the things that you have learned. So far, I have not received many of the worksheets done by you. So I encourage all of you to complete the worksheet as quickly as possible so we finish and pay attention to the second chapter. The second chapter is about measurement techniques. As the name of the chapter suggests, this is about measurements, and as we all know that physics is known as science of measurement because we make more measurements in physics than in any other branch of science. What we are going to discuss in this chapter are basically three different things. Number one, we are going to learn the use of various instruments in the lab. And if I go through the list given in the syllabus, I'm having this list in front of me. This is the syllabus of this chapter. This tells us which instrument we should be familiar with. Number one, we should be familiar with all the instruments we use for measuring length. And they include meter rule, Vernier caliper, and micrometer screw gauge. Screw gauge or gauge. Some students prefer to read it as gauge. I found it easier to say gauge. So screw gauge, Vernier caliper, and meter rule are three instruments used for measuring lengths. We'll come to the differences of these three instruments, how and why is one preferred over the other in a situation. We'll come back to that detail. I'll include all those instruments that we are going to use in the AS. We should also be familiar with the Newton meter. Newton meter or any other balance, electrical or physical, which tells us what is the weight or mass of an object. We might be using electronic balance in the lab to see what mass of an object has. It may be a physical balance, the simple physical balance in which you put mass on one side and the object on the other to see what mass in grams or kilograms an object has. Newton meter, which is also known as the spring balance, is relatively more commonly used instruments when it comes to measuring weight or mass of an object. Then we should be familiar with the use of protractor. Protractor, which is used for measuring angle, which looks like a D. So that is why it is also known as D. And it has a scale on it which looks like this. And this scale is used for measuring any angle between two lines. Then we should be familiar with the use of stopwatches, both analog type of watch or clock, and the digital one, which is available in all the labs now. So stopwatches and clocks. We should also be familiar with the use of CRO. CRO is a very accurate device, very sensitive device when it comes to measuring time intervals, and it is also used for measuring voltages. So it is also used as voltmeter. We'll come to that detail later on when we discuss CRO in more detail. Then we should be familiar with the scales on thermometers. How we read a thermometer scale is important. In the lab, we have a few experiments dealing with the heat and temperature, but we are many questions in the past papers in P1 especially, where a certain scale of thermometer is given and we have to read it accurately and report what is the correct answer to it. Then we should also be familiar with the reading voltmeters and ammeters. Voltmeters, ammeter. In fact, we use a device which is converted to both voltmeter and ammeter and ohm meter, and that is a multimeter, and we'll use that in the lab. Probably when you start coming to school, we'll have a timetable and that will follow, and go to the lab and see these instruments, use them with our own hands, because just by looking at these instruments probably will not have that idea which is required by the Cambridge. Cambridge requires that AS students go at least once to the lab every week and use these instruments frequently, so they become familiar with them and make calculations and measurements using these devices. At least as long as it doesn't happen, I'll show you these devices when we discuss them one by one. And then we have one more device that is galvanometer. Yes, let me add that to the list. Galvanometer will be used in one particular situation, and that will be the chapter of electricity when we are discussing those topics related to a device called potentiometer. There we use galvanometer, and that is only one situation where galvanometer will be used. Then we will also learn, other than these devices, we should also learn how we decide about a scale, its division. For example, how we calibrate this scale on a thermometer, for example. How do we decide that the scale has this size of the division and it has this particular range on a given thermometer? That is called calibration. That is also a part of this chapter. We'll study how we calibrate a scale, what are calibration curves, and what useful purpose they serve. And finally, the third thing that we study in this chapter is about some errors and uncertainties, some doubts that arise in the measurements, how we report those doubts, how we estimate them, how we eliminate them, or at least minimize them in our measurements. In other words, learning all this, and after learning the calibration curves and the calibration techniques, we'll have a comprehensive discussion of how a certain errors arise in measurements and how we make sure that our measurements are highly accurate, highly reliable. And if they are not highly reliable, what exactly is the size of that doubt and how we can take care of it. At least how we report that doubt as honestly as possible. So that is also an important part of this chapter. In fact, you will see that measuring those uncertainties, those doubts, will become ultimately the most important part, because there are so many questions in the exam. These are the instruments that you learn by going to the lab, by using them off and on. So it's not that demanding, in fact, from the examination point of view. If you have certain frequency of going to the lab and if you keep using them, you develop an understanding of these slowly. But practicing those questions in which we have uncertainties, in which you have doubts, that is more important from the examination point of view. And there are so many questions in paper 1 and paper 2. Let's start from the very first instruments that I have mentioned here, and then we'll take care of the remaining instruments one by one. Measuring length is therefore our very first topic of interest, and meter rule is therefore the first instrument that we need to understand, we need to discuss. A meter rule is most commonly used instrument and perhaps the simplest of all of them to use. A meter rule looks like this, and if I start from this side, it has a 0 here, and from this 0 we have a centimeter scale on it basically, and each centimeter is divided into exactly 10 millimeters. So if I show a millimeter scale on it, it should look like 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is your 1 centimeter. Is it visible clearly on the screen? Can you see the divisions? All right. So these divisions are the millimeter scale, and this large division is exactly 1 centimeter. That means we have 100 such centimeters on a meter rule, and therefore each centimeter with 10 millimeter in it, we have exactly 1000 millimeters on a meter rule. So a meter rule has exactly 100 centimeter on it, and therefore 1000 millimeter on it. We can measure any reasonable size of an object which has a few centimeters in length. Usually it is recommended that the size of an object that we are trying to measure with meter rule should have a size greater than 10 centimeter. Parallax, that we avoid parallax by keeping our eye straight to the level of the reading. If I'm taking a reading, let's say on this division, this one, I will keep the eye exactly here. Because if I keep our eye here, most probably we read this reading. So keeping an eye exactly parallel to the scale or in line with the reading. In line with the reading means exactly at the same level where the reading is. If you are reading it in this manner, your eye is exactly like this. If the scale is in front of you, your eye should be at the same level where the reading is. This is true for all scales, even if you are measuring the measuring cylinder or Newton meter scale is simply a scale vertical in front of you. So this parallax is to be avoided in all those cases. Sometimes its edges are broken. Usually we do not use such kind of instruments in the lab. They are always new with no wear and tear. But let's say in the exam they give us a situation like this. Then if we start from some other number instead of 0, we take care of that number, because this number means the object has, if this is the size of the object, this number, let's say I know this is 1.3. 1.3 minus 0.1 will be our reading. So necessary correction is to be applied if we are starting from any other position other than 0. If 0 is broken, if 0 is let's say not visible there, so in any such situation we apply the correction. So simple rules to follow using meter rule. But meter rule, as I said, is simplest of all, and by frequently using this scale we become familiar with these ideas. Let's move on and see what is Vernier caliper scale looks like and how we take a reading on a Vernier caliper. But before going on there, one thing that is important here to remember, and that will be discussed in more detail later on, that is the size of the doubt when we take the reading on a meter rule. If you are measuring something on this scale, let's say it's an object of this size, maybe it's a rod, and you have a scale like 1.1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2 centimeters, then 1, 2, 3, 4, 5, 6, 7, 8. Suppose this has started from somewhere behind it, and instead of 1 I assume this is 15, therefore it is 16 centimeter, and therefore it is the length of this object. If I start from this number happens to be, let's say, if I make it easier for you, it should be 14. And this is where it is starting. So it is starting from 14, and this is where it ends. What is the size of this object on a scale like this? It is 16, 1, 2, 3, 4, 5, 6, 7, 8. So this is 16.8 centimeters. And if I express this in millimeters, this is 168 millimeters. Let's say this object has started from 0, from where the scale starts. How will you report the length of it if it started from 0, 0 of this scale? That means it is exactly 168 millimeter. But is there any doubt in measuring this 168? We say yes, there is a doubt, because when we place it here, maybe its edge is here between these two, and we read it 168, and in fact it is slightly less than 168. It could also be slightly more than 168. That means on each end of its reading there is a doubt of 1 millimeter. So 1 millimeter doubt here, and 1 millimeter when we place it near 0 creates a doubt of nearly 2 millimeter. So usually when we make measurements with the meter rule, we report the doubt in the size of the object. If it is 168 millimeter, we add a doubt of 2 millimeter with this by writing in this manner. So every measurement made with a meter rule is reported in this manner. It could be any measurement of this size. As I said, it should be greater than 10 centimeter. So if it is 16.8 centimeter or 168 millimeter, there is a doubt of 2 millimeter. I can change this in centimeter as well. I can express it as 16.8 plus minus 0.2 centimeters. So this is same, just a different scale to say the same reading. The important part is why 2 millimeter? Let me go back and remind you that there is a doubt of full 1 division each time we report the measurement of the end of that object. If this is a rod with this end near 168, we report 168. It may not be exactly 168, but close to it. But it may be slightly less than it. It may be slightly more than it. That means an approximately 1 division is doubtful. So that doubt is repeated here and at the start when we place it near 0. So that doubt, which is maximum now, and we are honest about it, that yes, on this scale we have a maximum doubt of 2 millimeter if we are expressing that measurement in millimeters. And if that is to be expressed in centimeters, this is divided by 10, this is divided by 10, and both these numbers change to centimeter scale. So this is an important thing to remember, and we'll discuss it in more detail and what else we can do with this doubt. Now we come to the Vernier caliper scale. Again, that is used for measuring length. Vernier caliper. Vernier caliper has 2 scales. One scale is a centimeter scale, which is known as the linear scale, and we have a centimeter scale on it. There are millimeters shown. like we have on the meter rule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say this scale has started from left, from this point somewhere to the left, and this is where we have 5 centimeter, then 6 centimeter, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 7 centimeters. So this is a centimeter scale. We have a sliding scale on it, and that sliding scale has also divisions on it, and those divisions are 20 in number. They are closely spaced, and in between each two divisions we have one more division, and the total number of these divisions is 20. So if I start from 0 here on the Vernier scale, this is known as Vernier scale, and this is known as the main scale. So first of all, when we open the jaws of the vernier caliper, you must have seen vernier caliper in the previous classes. You're familiar with at least the shape of it. So when you open the jaws, put the object in between those two jaws, and the vernier scale stops here. The first thing that we note is the main scale reading. Main scale reading, MSR, that is the first thing that we note. And how we note is we see where the 0 of this vernier scale is. Is the vernier scale 0 has passed a value, has gone beyond a value, and has not crossed the next one. So let's see where this 0 of the vernier scale is. Let's assume this is the 0. So if this is 0, it is 5.123. So it has gone beyond 5.3, but it has not crossed 5.4. So it is between 5.3 and 5.4. So I will take 5.3 centimeter, or in other words 53 millimeter as my vernier, as the main scale reading. 53 millimeter is the main scale reading. Then the second thing is to note is what is the division on the vernier scale that coincides exactly with any one of the main scale reading. That is known as coinciding vernier scale division. For simplicity, it is denoted by N. I repeat, this is coinciding vernier scale division. That means any one of the vernier scale division which is exactly coinciding with any one of the main scale reading. So we carefully see which of the vernier scale division is exactly coinciding. An important thing to remember is here we have the numbers written as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means it is total 10 divisions numbered on it. From 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers written on it, including 0, 0 to 9, that means 10 numbers in all. But in between each two numbered divisions, we have one line, one division which is not numbered. So if we have, let me show by making a bigger scale. A Vernier scale looks like this actually. If you have a 0 here and you have 1 here, there is a division in between 0 and 1. If you have 2 here, there is a division in between 1 and 2. If you have 3 here, there is a division in between 2 and 3. So assuming that the division which coincide with the Vernier division which coincide with the main scale division is this numbered division, which is third apparently. You will be tempted to write 3 here, but 3 will be incorrect. This is in fact 1, 2, 3, 4, 5, 6. This is actually 6th division on this scale. So if it is 3 written on that, it is 6 in fact, which is the coinciding Vernier scale. What if it is a scale in between the two numbered divisions? Then it will be the next one, of course. If instead of this third one, it is the division, the line between 3 and 4, that will be read as 7th division. This will be 7th and this will be 8th. This will be 9th, this will be 10th. So although it will be written 4 here, it will be written 5 here, you will multiply it by 2, because in between each two division you have one more division shown. So that means if it is third division coinciding, that is 6th. If it is the division number 4 coinciding, that is 8. And if it is in between, it is simply one more division. I mean, if it is 4, it is 8th, and the next one is 9th, of course. So this is how you decide. After you have decided which one is the coinciding Vernier scale division, you simply multiply this division by the least count. Least count of this scale means the minimum we can measure using this scale, and it is written on the scale. It is 0.05 millimeter. This is mentioned on the scale. So we have a formula to remember how we make our final measurement, how we report it. It is 53, the main scale reading, plus 6 times this number, 0.05. So this will be our answer in millimeters. And of course, it could be expressed in centimeters if we divide it by 10. So I quickly repeat what is the procedure. We first take note of the main scale reading, where the 0 has just passed by. It is the division on the main scale immediately passed by the Vernier scale 0. So where the 0 has just crossed, that is our main scale reading. But then we look for the coinciding Vernier scale division, that division which is exactly coinciding in any one of the Vernier in the main scale reading. And I emphasize again that it is not the number that you should be deceived by, because the instrument we have in the lab is of this type. In between each two division we have one more division that makes it more precise. So if it is division number 1 coinciding, it is actually the second division. So if it is third division numbered there, it is the 6th. If I count from 0, it is 6th division. So I write 6 here, and this 6 is multiplied by this number, which is written on the device, on the vernier caliper, and I add this product to the main scale reading, and that is the length or the breadth or the width of that object that we are trying to measure with the vernier caliper. I stop here. We'll discuss micrometer screw gauge tomorrow and a few more instruments. We'll try to cover various instruments first, their scales, and then we move on to the second part, as I said in the introduction. Then we move on to the calibration curves and so on and so forth, then the kind of errors and how to eliminate. So it's going to be a technical, rather dry topic. So that requires you to pay full attention. Then it requires you to do a lot of practice, because this is the measurement. So this is not highly entertaining kind of topic. So I expect all of you to be very, very attentive and go through all this detail very carefully. Only then you'll be able to make sense of it. Thank you.